I made NumPy in C. Now, what is NumPy? NumPy is an acronym for numerical Python. It is a Python library used to perform mathematical operations much faster. More specifically, it is used for matrix algebra. Now, here is the thing. I love using the C programming language. And now since I am also an AI ML student, I need to be able to perform matrix operations. Unlike Python, which has NumPy to be able to do so, C has no equivalent standard library to perform matrix operations. So I made one. I made a matrix operations library using C for C. It's called matrix operations. And it is an entirely multi-threaded library. Now, what does that mean? Okay, in order to understand what that means is, simply put, every single app that we run on our system is inherently a process. For example, if I were to play a game, so when I open a game, that game runs inside of a process. Now, here is the thing. If a process runs all by itself, the amount of changes that it needs to make to the data within itself are too many, and there is too little time for those changes to be made. So it does what we call threading. Inside of that one process, it creates different threads. What that means is there are parallel commands that are being executed at the same time that have access to the same data, and that makes the overall runtime a lot faster and memory efficient. That is exactly what we've done in this library as well. When we call any matrix operation on the matrices that we have set up, say for instance multiply, so what it does is that it creates two parallel threads wherein each thread utilizes a technology known as mutexes and mutex locks. What that means is that ideally, or how it is supposed to work is that you have a certain variable, the threads, all threads all together manipulate the data inside of that variable. Now that can get really problematic because threads cannot communicate with each other, which is why we introduce mutexes and mutex locks. The way that works is that thread A will lock access to that variable. It will then manipulate that variable. Now while that variable is locked due to thread A, thread B cannot access that variable. It will be paused. Once thread A is done doing its job, it will then unlock access to that variable, and then thread B will now be able to access that variable. It locks it, it unlocks it, and the process goes on. This makes access to that variable memory safe, and it prevents all sorts of problems such as integer overflows, which was a huge problem that I had when developing this library. It was very painful. Anyway, so keeping that in mind, that is how multi-threading works, and this entire library is completely and fully multi-threaded. Now, how do we use a library? It's a really simple process. We include the header file. Once we've included the header file, we then define the matrices that we need to operate with. We then define the resultant matrix. Once that is defined, we then have to define what we call our data array. Now the data array simplifies the process of passing in the variables into the function. Instead of having to pass in the row count, the column count, and the matrix and the array addresses and all that stuff, instead of all of that jargon, all you have to do is to follow two fixed formats for the data array. We pass in the data array, our functions will then parse that data, and it will then very quickly operate on the matrices, do whatever task it's been told to do, and put the results in the resultant matrix, and there you have it. That, my friends, was matrix operations. This was a learning journey, and I greatly enjoyed working on this. It caused me a lot of suffering, but that was fun. Thank you. And there you have it. That, my friends, was matrix operations. It is available on my GitHub. Please follow my GitHub. Thank you so much.